This is Mrs. Boots, and we're going to work through the practice problems for variation. Problem 1. If y varies directly as x, pause there. Write the equation. Remember, directly means that we're multiplying. So y is equal to k times x. And when y is 6, x is 4. So they just gave us two pieces of information that we can use to find k. Then we want to find y when x is 12. So what is y when x equals to 12? This gives us a good outliner structure. Let's start by finding k. So I have y equals, so 6 equals k times 4. What would we do to get k by itself? Well, obviously we would divide both sides by 4. So when we do that, we get k equals 6 over 4, which we can then reduce to 3 over 2. Remember, this is only part. We have to take that and plug it back in. So let's write our new equation. We would have y equals 3 over 2x. Now we can take our x equals 12 and plug that in for y, so we can solve for y. So we'd have y equals 3 over 2 times the 12. Okay, so 12 divided by 2 is 6, and 6 times 3 is 18. So my final answer is 18. Number 2. A is directly proportional to B. So A equals to K times B. When A is 25, B is 35. So I have A equals 25, B equals 35. That's what we're going to use to find K. Now find B when A is 40. So that would be my other set of criteria. A equals 40. What is B? Alright, so back to the beginning. Let's go ahead and plug in to find K. What are we plugging in? 25 for A, 35 for B. Now how do we get K by itself? Well, we have to divide both sides by 35. Again, not a pretty fraction, but that's okay. We're going to reduce it. 25 and 35 are both divisible by 5. So I would end up with 5 over 7. This is my K value. Alright, so we're going to take that and plug it in to the equation, write it over here. So I would have A equals to my K value, 5 over 7, times B. Now what are we plugging in? We are plugging in A the second time. So I have an A of 40. That's equal to the 5 over 7 times B. Now this is where most students throw up their hands, but we're not going to. We're going to multiply by the reciprocal to get rid of that fraction. The reciprocal simply means we flip the fraction over. So 5 over 7 becomes 7 over 5. On the right hand side, it's going to cancel out, leaving just the B. Okay, on the left hand side, I have 5 divided by 40. Sorry, 40 divided by 5, which is 8. 8 times 7 is 56. So B is equal to 56. Number 3. W varies directly as Z. So W equals to K times Z. W is 4.5 when Z equals to 3. Find Z when W is 1.5. Alright, so first thing, remember, you have to find K. So we know that W is 4.5 and Z is 3. So we plug those in. Now we're going to have to get rid of that 3. So we're going to divide both sides by 3, right? And we get k equals what? Well, 4.5 divided by 3 is 1.5. Still not finished. Remember, we have to take that and plug it into the equation. When we do that, we get W equals, let's plug in our k, 1.5 times Z. Alright, now we got to plug in the W value to find our final Z value. So I have 1.5 equals 1.5 times Z. Well, this is going to be anticlimactic, right? Because we all know that when I divide any number by itself, I'm going to get a what? Yeah, I'm going to get a 1. So Z is equal to 1. Number 4. If P is directly proportional to Q cubed. Okay, remember the Q is cubed, so we keep that in the equation. When P is 3, Q is 2. And then we have the second criteria, find P when Q is 4. So first thing, let's find K. So I have to plug everything in. Q is 2, P is 3. So I end up with 3 equals to K times 8 because I have to cube the 2. Now we can get rid of the 8. We would divide both sides by the 8. And yes, K is a fraction. And it's 3 over 8, which we do not reduce. But we're going to take it and plug that in. So I get P equals 3 over 8 Q cubed. Alright, now we have to plug in the second criteria. So we have P equals 3 over 8 times 4 cubed. Now what is 4 cubed? Yeah, that's 64. So I have 3 over 8 times 64. Okay, so 64 divided by 8 is 8. And then 8 times 3 is 24. So my final answer would be 24. Number 5, y varies directly as x. Well, that's just a simple equation. Y equals k times x because it's directly. Criteria 1. Y is 16 when x equals 64. Criteria 2, find y when x equals 24. Alright, so let's plug in and find the k values. I have a 16 and a 64. What am I going to do to get 64 by itself? Or k by itself? Yeah, we're going to divide by the 64. So I have k equals, let's reduce that fraction, we get 1 over 4. So this is what we would plug in for k. So we're going to take that with our equation and plug them in. So I have y equals the 1/4 times the x. Now we plug in our second criteria. So I have y equals the 1/4 times 24. Okay, so what is a fourth of 24? Or what's 24 divided by 4? That's 6. So my answer would be 6. If R, number 6, if R varies directly as S plus 1, so R equals to K times S plus 1. This one's a little different. We haven't had a binomial in there. Okay? When R is 4, S is 5. And then we want to know what R is when S equals to 8. There's our second set of criteria. So let's plug in to find K. I write everything down except for my R and my S. So my R is 4, my S is 5. Now let's simplify. I get 4 equals K times 6. Get rid of the 6, we're going to divide. And we get k equals what? Yeah, 2/3. So that's my k value. I'm going to take that and plug it into the equation. So I have r equals 2/3 times the s plus 1. Now we're ready to plug in our second set of criteria. So we have r equals the 2/3 times the 8 plus the 1. Okay, so 8 plus 1 is what? It's 9. So I have 2/3 times 9. 9 divided by 3 is 3. 3 times 2 is 6. So r equals to 6. Number 7. P is inversely proportional to Q. Okay, this one's different. Inversely means we're dividing. So that Q goes in the denominator. But we're still going to get two sets of criteria. When P is 10, Q is 5. Second set of criteria, find Q when P equals 2. So let's go back to our first set of criteria and plug in our numbers. P is 10, Q is 5. Now in this case, pretend there's a 1 under the 10 and we're going to cross multiply. So I get K equals to 10 times 5. What is 10 times 5? Yeah, super easy. It's just 50, right? That's my K. So I'm going to plug that into the equation. So I have P equals 50 over the Q. Now we can plug in our second set of criteria to find the answer we're actually looking for. Remember to plug it in for the correct variable. I just drew an arrow to the wrong variable, so double check and make sure you've got it plugged into the right side. So P is 2, and that equals to the 50 over Q. Now I can still put the 2 over 1 and cross multiply. Not a big deal. I'm going to get 2 times Q equals to 50. What do? Yeah, we're going to divide both sides by 2, and we get Q is equal to 25. That's our answer. Number 8. X varies inversely as the square of y. Okay, so X, it's K over, because it's inversely, and that's y squared. The square of y is y squared. Easy enough. What's the first set of criteria? When X is 2, y is 12. Second set of criteria, find y when X equals to 8. Okay. So first thing we have to do is plug in. Remember, you're squaring whatever you plug in. So I have a 2 for X and a 12 for Y. We can still put the 2 over 1 and cross multiply. So we have a fraction equal to a fraction. So I'm going to get K equals, that's 2 times 12 squared. You got to think about this. 12 squared is 144. Multiply by 2, you get 288. That's a big number, but that's okay. Big numbers happen in life. We're going to plug that into our equation. So I get X equals 288 over Y squared. Now I can plug in my second set of criteria. Make sure you plug it in for the correct variable. The 8 gets plugged in for X. It's over the Y squared, and we still have the 288 on the top in the numerator. And fraction equals to a fraction. We can cross multiply. And we see that 288 equals to 8y squared. The first thing I have to do is get rid of that 8. So we're going to divide both sides by 8. And I get y squared equals 36. Now what do we do to get rid of a square? Yeah, we're going to take the square root of both sides, and I get y equals 6. That is my final answer. Number 9. I varies jointly as P and R. So my jointly, we're going to multiply. So I have K times P times R. So we're multiplying everything. If we were going to divide, it would have said inversely. Now what's my first set of criteria? I is 14 when P is 100 and R is 0.07. That's kind of crazy. Okay, so I'm going to use that to find K. What's my second set of criteria? I is 48 when R is 0.08, and we will use that to find P. So first step is to find the K. So I'm going to have to multiply P times R and plug in my I. I is 14, P is 100, R is 0.07. Well, we made it really easy, right? Because 100 times 0.07 is what? Yeah, it's just 7. So what do? Divide both sides by 7. And super easy, 14 divided by 7 is 2. Okay, so K is 2. Now let's take that and plug it in. Get one equation. So I have I equals 2 times P times R. Now I can plug in my criteria. So I've got an I and I've got R. So I is 48. I still have my 2. I still have my P. And now I have an R value of 0.08. Now remember, you can multiply the 2 times the 0.08 to simplify. So we're going to have 48 equals 0.04 times P when we multiply those two. Not 0.04. Let me try that again. It's 0.16. Okay, I was dividing. It's multiplying. 0.16. Now we can divide both sides by 0.16. And P equals to what? $300. Number 10. X varies jointly as y in the square root of z. So x equals ky square root of z. Alright, that's kind of crazy, but we can do it. Now the first set of criteria. X equals 20 when y is 5 and z is 9. We're going to use that to find our k in just a minute. Second set of criteria, we're going to find x when y is 6 and z is 25. Alright, so first we have to find our k value. Make sure you're plugging everything in appropriately. So that z does go under a radical. So x is 20, y is 5, z is 9. Now let's simplify. So I get 20 equals k times 5. The square root of 9 is 3. So that's 20 equals to k times 5 times 3 is 15. Now we got to get k by itself. We're going to divide both sides by the 15. And k equals what? Well, it's not perfect. So we're going to have to reduce the fraction. 20 divided by 15 would be 4 over 3. That's easy enough. We can take that and plug it in to our equation. So I have x equals k, which is 4 over 3, times y times the square root of z. Now we can plug in. So y and z. Plug those in appropriately. So we get x equals 4 over 3 times 6 times the square root of 25. Well, that's cool. It's all on one side of the equation, so we can just simplify. So I have my 4/3. I'm just going to keep that the same. I have 6. What's the square root of 25? Yeah, it's 5. Alright. So there's two ways to do it. There's actually more than two ways to do it, but 5 times 6 is 30. Okay, so I'm going to scribble that in as a little note. So I have 30 divided by 3 is 10, and 10 times 4 is 40. So x equals to 40. If you don't believe me, you can plug the whole thing into the calculator with the parentheses. Number 11. Now we get the fun problems. They don't tell us the variables. We get to decide what the variables are. So intensity is registered by light, varies inversely as the distance from the meter of the light source. So I'm going to have intensity be I, and it's inversely, so I have K divided by the distance. So I'm just going to pick D. First letters is usually the best thing to use so you can remember what it stands for. Now they should have given me a first set of criteria. A light meter is 5.4 meters from the light source. So my distance is 5.4. And the light source registers 20 lux. So that would be the intensity. So now the second set of criteria. What would intensity measure? So I'm looking for intensity when my distance is what? 1.8 meters away. So now I have enough information to find my K. I'm going to plug that in. I have 20. I have 5.4. Remember, it's a fraction. So I can put the left side over 1 and cross multiply. So I get K equals 20 times 5.4 is 108. So my K is 1.8. Let's take that and plug it into the equation. So I have I equals 108 divided by D. Now we can plug in our second set of criteria to solve. So I have I equals 108 divided by 1.8. This should be interesting. And we get 60. Now what were the units? Oh yeah, they were lux. Make sure you include the units on word problems. Number 12. The frequency of a radio signal varies inversely as the wavelength. So I'm going to have frequency inversely means we divide by the wavelength. Again, I picked first letters. I know, it's not very original. The signal of the frequency is 1,250. So when F equals 1250, W is 240. Now look for the second set of criteria. What is the frequency when the wavelength is 300? Easy enough. Let's plug it in. So my frequency is 1250. My wavelength is 240. We put the 1250 over 1. Cross multiply. That's going to be a big number, but that's okay. So K equals to 300,000. Remember, there's no units for K. It's a constant. We just use it as the relationship or the ratio between two things. So F is equal to my 300,000. Make sure you get all the zeros in the right spot. Divided by the wavelength. Now we can plug in the second set of criteria to find the answer we wanted to find to begin with. My frequency is equal to 300,000 divided by W. W is 300. That's going to be interesting. Let's see. That cancels, that cancels. So I did 3 into that, and I should have a frequency of 1,000. Now look for the units. What was frequency? Kilohertz. Make sure to include the units in your final answer. Number 13. In a survey, the number of people preferred hot cereal is directly proportional to the total people surveyed. So I have hot cereal. Directly means we multiply times the number of people. Easy enough. So now the first set of criteria said 52 preferred hot. So hot equals 52 out of a total of 234. My second set of criteria, they want to know how many hot out of a total of 1,800 people. Alright, so let's figure it out, plug it in. So again, we're multiplying. My people is 234. My hot is 52. We're going to have to divide by that 234 on both sides to find the K. I wonder if it's a fraction. Let's use a decimal on this one. It's going to be 0.22. Since we're dealing with a percentage of people, that's okay, because that's basically 22%. Alright, so we got 0.22. That's what we're going to plug in to our equation. So I have hot equals 0.22 times my people. So now I can plug in my second set of criteria and solve. H equals 0.22 times, how many people do we have now? 1,800. So H equals what? Plug it in the calculator and we get 400. Remember, you can't have half a person running around. So make sure you truncate it if it doesn't come out to a perfect whole number. I should have written down the units. Let me write that in. So it's 400 people prefer hot cereal. Number 14. In real estate, the commission is directly proportional to the price of the property. So I have C equals to K times P. So an agent received a commission of $2,232 on a property that sold for $124,000. Okay, so they just gave us the first set of criteria. At this rate, what commission, so what are we looking for, commission, will the agent receive for a property that's priced at $160,000? Well, let's figure this out. And yes, real estate agents really do estimate their commissions. So what would we plug in? We're going to plug in $2,232 for commission and $124,000 for our price. And yes, you divide both sides by $124,000 to get that percentage that the commission is. So let's see what that is. I plug it in the calculator and I get 0.018. Okay, that means the real estate agent's getting 1.8%. They usually make about 3%, just as a data point for you. That's what they put in the legal contracts nowadays. Okay, so let's put that in our equation. So cost equals 0.018. Remember, you have to use the decimal value, not the percent value, times P. So now we're going to plug in that price, that P. So C equals 0.018 times 160,000. Plug that into the calculator, and I get $2,880. Not bad. Again, 1.8% is low, so this realtor is giving a discount for some reason. This concludes all of our practice problems for variation.